Hello, my name is David Orlando. I'll be going over my project today, which is a predictive versus realized vulnerability analysis. This project examines how predictive models align with realized exploitation of vulnerabilities and different exploits using three major cybersecurity data sets, which is exploit prediction scoring system, the National Vulnerability Database for common vulnerability scoring systems, and then the CISA known exploit catalog, which has got an acronym of KEV for some reason. So really the question in my project is, does predictive priority really align with what the realized vulnerability exposure is in the real world? Basically, are we predicting what is getting exploited? For this, I'm comparing CVSS severity scores from NVD, which is basically how the severity of those vulnerability exploits are once they do happen, when they do happen. The KEV database, which basically confirms an exploit actually did happen and it was made of record, which is much less of a likelihood because not all of them get put into that record, but that's what we're going to use. And then EPSS scoring, which is basically the prediction and predictability of what vulnerabilities are going to be a problem and how likely those are to happen. The real goal here is to assess, by combining all these and providing a predictive model to see if we can guide patching prioritization more effectively to prevent different exploits and different leaks from happening. So really the data sets, again, I used were the NVD using CVE records. The CVE ID was basically a shared key across all three different data sets, and the overall span of time for these is really a decade. So it's beginning in mid 2015 all the way up until October of this year, so 2015 to 2025. Together, these data sets really let us compare severity and volumetric impact with real world exploitation probability. So the raw data from these sources was pulled in a significant way. I cleaned it, integrated it. In Python, I pulled all three data sets using APIs, pulling standardized fields, removing duplicates, and then merging them all into one single CSV file. This created over 232,000 rows of standardized data. With that, I exported it to Tableau for visualization later. I also created several calculated fields to enhance the analysis, basically calculating CVSS severity through a kind of a ratio model using EPSS high predictability scoring, basically taking the risk of exposure and the severity that exposure would be. I calculated the age just by date entered and date modified, and then the resolution or mitigation date of when a vulnerability mitigation was put in place. The alignment category to basically align it to a high, medium, low, both in predictability and severity. Different SLA breach, positive or negative. I also created bins to create both a kind of a practical and then a rational cluster analysis. And I created normalization scores that would be basically a variable used for later to see if we're missing anything from cleaning the data set. As far as techniques, there was quite a lot covered. I did the analysis in Tableau. I used several different techniques, each designed to highlight a different aspect of the problem. First was a scatter plot comparing CVSS scores to EPSS likelihood with KEV indicators throughout to show us where an exploit was actually recorded in industry. Risk matrix heat map showing vulnerabilities across severity and likelihood bins with KEV, split out KEV indication across those bins. Then I did a cluster analysis aside from the calculated bin field, which incorporated age and the percentile used with a scatter plot. I then provided a CWE-to-Product heat map to identify weakness and trends across different products, vendors, and really everything in the industry as far as technology goes. I also did a predictability or an NVD scoring across different years, and really that can be expanded to months, but it became too cluttered to present here by way of months. And then a prioritization table, which I believe is superior in many respects to the different remediation spreadsheets that, for example, the risk management executive uses today. So to first go over the scatter plot, it really revealed both expected and surprising results. Many of the vulnerabilities fell into a high CVSS score and a high EPSS score, showing a real strong alignment between predicted severity and exploitation, which is good. It means that cybersecurity teams are focusing on what is being indicated as the most priority. The issue is that there was outliers that did come up, which are vulnerabilities that had high EPSS predictions, but low CVSS exploitation scores. A lot of times this was with unique and non-name brand products, but this indicates that we had high likelihood of prediction, but it didn't happen. It just did not get realized in the real world. Conversely, some of these vulnerabilities had high CVSS and low EPSS scores. Some of these were patched quickly, which means cybersecurity teams were responding well to possibly zero-day exploit notifications. But in terms of the data, this indicates we didn't predict it, but it happened and became a very big deal. So for the cluster analysis, I took the scatter chart and applied a cluster on it, factoring in age of vulnerabilities across 3 clusters. Due to how many entries were present, I actually filtered this down to Cisco as an example and Cisco-related products, just because there's so many entries. So most clusters still showed a positive alignment between CVSS and EPSS score, and even crosswalk to whether it was present in KEV or not very reliably. But the Cisco ASA appliance and RV series routers really stood out as an outlier, where vulnerabilities remained unresolved for far longer than expected, even with both predictive and severity scores flagging them. And then even some of those showed up in the KEV database, and they were indeed exploited. This highlights blind spots in the predictive models, and it also highlights blind spots in the way that our cybersecurity teams are being productive or prioritizing. So next, for the risk matrix, this showed that most vulnerabilities were medium or high severity, but low likelihood of exploitation, and there was a low transition from these across categories with respect to KEV presence. This is encouraging. It means that many vulnerabilities that were critical or rated high were addressed, and the ones that were addressed were not respectively flowed into the KEV database, meaning they weren't exploited. That means our cybersecurity teams are working and they are doing good. But what I did find is that medium level vulnerabilities appeared under-resourced and were under-resourced, and this really shows a potential blind spot in patching strategies. Much as this didn't transition over into the KEV database, it was less than 1%, but really even 0.5% or even 0.25% can be a big deal in the technology sector because that leads to a breach. The CWE and product heat map highlighted recurring weaknesses and types of weaknesses across product families. Again, I narrowed this to Cisco just because the data set is so large and there's so many products and technologies listed. Through their product lines, it showed a broad coverage. They are doing a relatively good job. One thing that stood out, though, is RV series routers and the different appliances they offer, specifically the ASA appliance, really came up as an outlier with concentrated medium severity vulnerabilities that remained unaddressed for a long period of time, which shows that this data could show Cisco that, hey, you need to put some focus here. So the next analytical technique is the prioritization table, which emulates a remediation spreadsheet that's actually in development in our production environments today. So this really revolves around really what risks and ranked vulnerabilities really show as being a problem over time. So basically using combined severity, likelihood, SLA status, with the alignment categories I set up, so this has a little bit of a clustering to it, it created a practical patching queue. It's noteworthy that this is similar but greater in detail to the remediation sheets that are being used on, especially, for example, DISA contracts today to remediate different findings. Notable findings on this include high priority items in buffer overflows across several different products. Some surprising areas were like hypertext template language. I didn't expect to see that. And then there was definitely some, certain Adobe products like Acrobat that had exploits that are still outstanding that haven't been remediated, and they don't have a path forward for remediation. To narrow it down to Cisco specifically again, the table flags certain APIs that they have. Several Comcast branded Cisco products were listed in a very big cluster of different CVEs, some WebEx exploits, and then the RV routers came up again, which just weren't fully predicted by EPSS, and they were outlier in predicted priority and actual addressed and focused priority in the real world. So for the last analysis chart, I wanted to kind of take a step back and give everyone like a bird's eye view to really show the importance, the growing importance of a project like this over time, which is the NVD exploit severity records across the last decade. Meaning this is a very simple chart. It only shows severe exploits rated over a period of time based on their age. This shows really between 2015 and 2025 a near six-fold increase over the last decade. And this only accounts for exploits that NVD recorded. This doesn't count for everything because NVD can't capture everything. I mean, really, to me, this is the clearest picture of an exponential increase in studies like this and data analytics like this that really could even be drawn. These exploits affect businesses, agencies, and most importantly, lives in the number of millions. You know, we can do better with analysis like this to support vulnerability prioritization, and we should strive to do better. So as far as takeaways from this analysis, it really shows that predictive models like EPSS really align well with realized risk, but they're not perfect. Medium to critical vulnerabilities are often overlooked despite their volume. Vendor blind spots exist, especially with the RV series routers as an example. Remediation sheets could be more refined, and prioritization using analytical models like this between the already used public data sets can really help cybersecurity teams be more effective and more efficient. However, this study was limited to a 10-year time frame. A lot has happened much longer back in time, and it also only uses 3 data sets. And the cleaning methods to reduce the potential vulnerability inclusions like duplicates and different malformed entries was pretty rigorous because I wanted a clean data set. So better programming in terms of capturing more of that data could definitely help this study. Expanding in a time horizon, incorporating additional sources would definitely help. And I think pulling this into a SQL database to really dissect and unpack the data a bit better would definitely help. Have these different analytical models be more refined, and getting a larger set of rows of the past and would definitely help. So in summary, this project demonstrates the value of combining predictive, descriptive, and exploit vulnerability data to improve prioritization. I did this by aligning CVSS, EPSS, and KEV data databases. And using this data, we can identify security posture gaps, identify blind spots, and guide more effective remediation strategies. And that's it for my presentation. So thank you for indulging me. So for the last bit of the assignment for this discussion, it has to go into the hardest and most interesting part of this course and this degree overall, which I found to be pretty closely aligned. The hardest part of this course, and really the degree itself, is probably the same, and that's being efficient and saving everything that you do, and not just using the same thing over again, but templating everything. And anytime you run into an assignment that's very similar, repurposing what you've done before and leveraging that to what you're going to do for that assignment. And that is just imperative. I can't stress enough how much time you could waste redoing and recreating everything. And the point of the degree is to build an accumulation of knowledge and build a platform of understanding that you slowly stack over time and become more and more capable. And if you don't do that, I just don't see anybody doing very, very well in this degree. You may pass, but you're not going to do very, very well. And if you don't re-leverage what you learn regularly, you'll lose it, and it just won't be helpful in the future. I think as far as the most interesting part of this course and the degree again overall is probably the alignment with what I'm doing today. I am a program manager and a solutions architect that works with information systems, data, technology, and solutions all the time, every day, throughout the entire year, year after year. And this course is something that this course and actually the degree overall is something that I would recommend to really anyone that's pursuing this type of degree or this type of career and this type of job role and tasks. I mean, it really reflected a lot of the building blocks that you really need to be able to do this. And if I was to highlight that even more, there was definitely aspects in the degree that I haven't dealt with that I wish I would have had years ago. And that is something valuable. And I think everybody should hold to heart. So that's my presentation. It's been great learning with all of you, and I wish you all well.